Okay, good evening and welcome to this new lecture where we're going to start a new topic that we um, mentioned last time. Before that, let me share my screen. I want to show you two things, please. If you go to the e-learning page, I didn't post anything new. Well, except the routine things, the recording of the last lecture. And again, I want to remind you about in the first section in the e-learning page, and I tried to make you a nice banner. I don't know. Class schedule. Here I try to tie three things together. I tie the topics that we cover in each lecture. Okay, each lecture, the topics we cover, the presentation slides we use, and the recording we of the lecture we had. Okay, so all three things tied together. Just a reminder, I mentioned that before, but if anybody missed it. Another thing I want to remind you of, to install the Code Warrior version I have here, if you didn't do yet. Please install it. I think if not this class, next class, we're going to start writing code. We're going to use it. And I may be posting a new homework this week. I'll try to notify you through the notifications in case I post anything that needs attention from you, especially homeworks or lab assignments. But you're aware of the two main milestones, the two main major assignments, the design project and the research topic. Okay, so please keep your eye here and start, always keep thinking of it and work on what you can do. Finally, the discussion forum. I see 14 replies to my post. While I asked everybody, it's mandated that everybody submits before this class. So I still have 3 people who did not post their responses. So if you didn't do so, please do it before tomorrow morning. Okay, I'm gonna tolerate until midnight or tomorrow 8 a.m. Okay. I just want to know what you're doing. So please post your response to this discussion. Then I want to mention one more thing. Most of you started looking for papers and papers for their research topic. So a very simple way to do that, just an advice. Many of you already know how to do that, but I would advise you to start when you search for a topic, how to find good papers. You use this website, scholar.google.com, and here you just search. If you want to search, for example, for embedded hardware security, مثلا, you get a lot of papers. Okay, every paper published in any known index or database with the keywords you mentioned in your search, you'll get it. Now, many of your research results, you will get access to the source PDF, okay, on the right side. If I like this paper, I can just open it if I have this link here. And there are some indicators about the paper. For example, this one is cited 14 times by other people. This one is cited 346, so it's a book. It must be a good reference. This paper by acm.org, ACM is a well-known, just like IEEE organization in computing, is probably ACM is a good source. So this could be a good paper for you in your topic, مثلا, cited 100 times. So you can open it directly if the link is available. This is the paper. You can download it, read it, whatever. Or if you don't have this link, again, you can search for any topic. If you don't have this link, مثلا, this is for Wiley, from Wiley online library is well known. Springer, for example, this paper from Springer. If you want it, you either buy it, okay, you either buy it and pay 74.89 euros, or you get access to this database through your institution if it is authorized. Again, MDPI. MDPI is usually open source. Okay, so open source library journals, you would find their links. This is from Springer, مثلا. IEEE, Journal of Emerging. You know why? You may not see. I don't know if you search. You may not get this link. You may not. I think I get it because I'm logged in. Let me tell you log in to where. IEEE journal. But, for example, I want this journal, okay, and I don't have this link. You can just go to this link, copy. It will take you to IEEE Explore if it's an IEEE paper, and you can copy, for example, the title of the paper. ماشي? Then you go to login.psut.idm.oclc.org.login. Where would you get this link from? From the library website of PSUT, library.psut.edu.jo. And if you don't have an account, they're very helpful. And this is how I got my account. So if you go to library, electronic resources, these are, PSUT has access to all these electronic resources. IEEE Explore is included, ACM is included, Wiley Online is included, okay? And they have a video how to use it, which is good, okay? And you can request training and some open access resources. Okay, how do you log in? How do you go to that page? Maybe in their video they have a link or something, but we should have something easier here. Search ebook journals, open resources, open resource search books and journals. Let me see.
او دكتور ممكن على الاي تريبل اكسبلورر لو دبل كليك تفتح معك اتوقع كموقع.
If you have access, okay. Now, if I am on campus, if I was in my office at the university, I don't need to do anything of this. I just do search. I search using Google Scholar. ماشي. I search. Then, if I am inside the university, it will open, because it will take your IP address from the machine in the university. But I'm talking if you are outside of the university, at home, for example, just like my case right now. I'm not in my office. If I was in my office, everything will be, yes, I can just click on the paper. This one is IEEE. I would just click on it. Over here, it will take me to IEEE Explore. The PDF will be available. Tamam? However, I'm talking about a case that if you are at home, you know what? I'll just give you this copy. I'll copy this and put it for you in the chat right now. You can just save it. How do I send you a chat message now? Okay.
دكتور، هو بجوز مصطفى كان قصده لو تكبس على الصورة نفسها بفتح لك هذا الويب سايت.
انا هيك قصدي دكتور، يس من هناك خلص بيطلبك اليوزر والباسورد اللي هو تاع المكتبه، وبيكون اوبن عندك كل شيء.
From the website, from IEEE Explore.
لا من الويب سايت بتاع اللايبرري، مش حاطين صور اي تريبل اي وسبرينجر واي سي
Okay,
ام.
okay. On this?
يس.
يس.
Oh yeah, it will take you to.
ايوه
Yes, this is the
بس
one.
الباسورد لازم.
Now you
يس.
need a password, a username and password. How would you get this username and password? You know how I got it? Very easy. I just click this live chat at daytime working hours. They'll be responsive. Chat with them, tell them, okay, I am a student. They ask you for your ID number, whatever, okay? They're very helpful. If you have any issues, you can even call the university, ask chatbot. See, they're hi, how can I help you? Just talk to them, and you get access. When you get access, you log in, and this is how I got my access at home. And the paper I just found is IEEE, okay, مثلا, or Wiley or ACM. Okay, go to IEEE here. Now I get access to the library, you don't have to pay. See, it recognized that this is provided by PSUT. I search for the title again, that I found on Scholar, مثلا this one, okay. I search for it again, and you get full access. Okay, this was just
Doctor, the other day I was searching in the IEEE website. Yeah, see here on the left side there is show all results, subscribe content, open access only.
So we were able to see this one in the search because it is open access. Okay, but if it was not open access, I wasn't gonna be able to get this PDF access or this link here because it's not open access. It happened that this one is open access, but if it's not open access, you will not be able to access it from here directly. You would need to do what I did right now. I go to library website, log in, then search for it, and you get it, even if the lock was there. Okay. Sometimes, open access is something that a lot of people are doing right now, but still yet a lot of good research is still not open access. Okay. Just thought to give you this quick demo about how to search for your papers. Okay, let's go back to our.
Doctor, a question here, if possible.
Yes, sure.
Is it mandatory to have a research paper published on IEEE and Thomson Reuters, as you mentioned in the text, or should be anywhere?
Well, Thomson Reuters, it's not Thomson Reuters anymore, ISI. Clarivate, Thomson, if you write Thomson, ISI, Thomson Reuters journal list, it's smart to send you to Clarivate. Okay, this is it. So this indexes most of the reputable journals. Okay, so all ACM journals are there. Most of them, let's say, most of them, 95% or more. IEEE, almost all IEEE papers are in there. MDPI, most of their journals are there. What else? Most of them are there. If you want to verify if a journal is there, you can search for it here and you find it. مثلا, the one we just found here, let's say you want to work in embedded hardware security, you want to check this journal if it is let's say if it is in ISI. We call it ISI for short. It's not an ISI anymore, but many of the journals on their website, by the way, they have a section here somewhere about indexing, and they tell you if they are indexed or not. For example, let's see. We know ACM is indexed. So if you go here, publication proceedings. Proceedings is a conference or workshop. It's not journal. Okay, but yet it could be still indexed. Wiley. So what is this? This is a journal, international journal. If you want to get its name, you can get it. مثلا, where is the name of the journal? International Journal of Circuit Theory and Applications. You can just write that or copy it. It looks like an open access. Everything is here. Or copy the ISSN. Okay. Well, you know what? This is the PDF copy. I just want to copy the name of the journal, or it's here, International Journal. I copy this, copy, and go back to this in search engine for journals. See, it found it. So if you find it, if you find it, it is indexed in Thomson. This is in Science Citation Index Expanded, part of Clarivate now. We used to call it Thomson ISI. So this is a good one, okay? Now, I'm not saying that any other journal that is not here is bad, okay? If you really find a topic, but sometimes, unfortunately, there are journals where you pay like a few $100s and you publish anything. We don't want those. So if you feel that you find a good journal paper with a very interesting topic and has content you believe you can build on, along with the other two journal papers you're going to find, I may allow that. No, it's not a big deal, okay? But I just want to make sure or verify that you guys find good published papers with an acceptable amount of reputation, where the results are not just published without peer review or enough review, okay? So if you hesitate about a title, a journal title, you don't find it under, even, you know what, I accept Scopus if you want. If it is under scopus.com, go to scopus.com. Scopus is a wider index database. Most of the papers under Clarivate or Thomson are there. But if you go to Scopus, Scopus source list here, download it, open it. Any journal listed here, it's opening an Excel sheet now in a second. Scopus source list. Okay. Opening, it's a big list. And I'm dragging it. Okay, source, this is updated October 2020. You just copy the journal name, search for it here in this column, Control F, Control V, for example. Most likely you're gonna find it, see? International Journal of Circuit and Theory. So if it is in this list in Scopus, I'll accept it. ماشي. Scopus includes almost all the ones in ISI plus more good ones. Scopus is acceptable. Scopus.com. And on the same page, you go to the source list, download it and search within it. تمام طلال؟
تمام يعطيك العافية دكتور شكرا.
Okay, let's go back to our class topic of today. We're gonna continue talking, and we just introduced the topic last time, HCS12 addressing modes. I don't like this. Why does it keep happening? Swap. Show. Oh, okay. Toggle. Hide presenter view. Okay. And I want to swap. Okay. It's on my other screen. I'm sorry. Okay, swap, then swap, then I hide. Okay, sounds good. So we said last time that addressing modes is the way that the CPU accesses the operands in memory. Okay, we said that a machine instruction consists of an opcode, the machine code that says that I'm going to add, or I'm going to subtract, I'm going to multiply. Multiply what? A and B. Where are A and B? These are called, the A and B are the operands. The addressing modes decide or tell us where these operands are at. They're in memory. Here is their address, or their address is somewhere else, etc. And we said that the opcode of any machine instruction is either 1 byte or 2 bytes. Okay, 1 byte or 2 bytes. Any 2-byte instruction starts with an 18 hex. Okay, so any machine code is either 1 byte or 2 bytes. I don't see it. 2 bytes. Any 2-byte instructions start with 18 hex, then the other byte. Okay. And this is the list from the datasheet and book about all different kinds of addressing modes. I try to simplify it into 6 main categories. First category is the inherent addressing mode, immediate addressing mode, direct, relative, indexed, indirect. And some of them has even more details. We're going to go on one by one. These are the basics to understand what's going to come later. So let's understand them very well. The inherent addressing mode means that the opcode that the operation is going to perform on is inherent within the instruction, within the opcode. So example instruction nope, yani no operation, do nothing, just waste clock cycles. There is nothing to go do in memory, no operand. NX, INX means, how do I know that this means increment X? Increment X. We know that X is a register. INX is increment X. Yani it is almost impossible to memorize all the instructions. That's why we have the instruction set table and the manuals, and I shared with you last time. And you can see and learn how each of the instructions would work. However, coming ahead, we are gonna cover most of the important instructions and learn how to use them. But if this is the first time you hear about an instruction, just go search for it. Search for it in the instruction set. Okay, I don't want to keep jumping, but I showed this in the last class, and we're gonna go to we're gonna use the data sheet again. Anyways, the increment X, there is no operand after the mnemonic. That is the opcode. So the zeros and ones representing this, the INX 0, 1, 1, 0, whatever, this is the opcode. And there is nothing representing X here because X is inherent within the instruction. It is part of the machine code. So if I ask you, where are the zeros and ones that tell me that I'm going to increment X, not Y? They are they are embedded within this machine code. Okay. No separate addressing for X. It's part of the instruction. Increment X, and we saw it, I think, last time. Increment X is tells the processor to go to register X, add a 1 to it, and store the result in X. This is increment X. Okay, incremented. Decrement A, same. It decrements the number inside register A and saves the result in A. Okay, so A minus 1 will be stored in A. The point here that A is not separately mentioned as an operand. Okay, it's not an operand. It's part of the machine code. So if it's the zeros and ones representing A are within the opcode in the program memory. So this is the first addressing mode and the easiest. Hope it's clear. Any questions on this one? Okay. And by the way, I just remembered as this university is working on the midterm exam schedule. The exams are gonna start in week 8 up to week 10. Okay, we're allowed to use week 11, but I don't prefer that. So the date I have in the proposed schedule in the schedule page of our midterm was May 5th, and this is week 11. I'm open to keep it or bring it a week earlier, okay? And think about it. I'll do a poll next time, inshallah. And according to the instructions from everywhere, all of you need to be prepared, and you all need to turn on your cameras and have your IDs next to you to be shown to whoever asked for them at that time. So please, if you don't have a camera, your camera is not working, you never used it, make sure it works at that time. And because I don't know you guys, even in class, I don't know you. So you need to present an ID. I'm sorry to say that, and this is the first time it happens, but you need to present an ID. And talking about the exam, and since we just started with the content and material, I never did any closed book exam in my last 10 years. So the exam is going to be open book. Okay, so keep that in mind when you study. I don't want you to memorize things. I want you to understand. And don't forget to write your name and ID in the chat if you didn't do so yet. Second addressing mode is called the immediate addressing mode. Immediate addressing mode. In this addressing mode, this sign, the hash sign, is used to represent immediate. So this instruction, load accumulator A, number sign, hex 55, will put load accumulator A, will load accumulator A with a number, I'm going to say, rewrite it again, 55. Yani, if you draw it, A will have 5 hexadecimal, yani 0101 0101. So in this addressing mode, The data is available within the instruction. It's not inherent within the opcode, but it is still within the instruction. I directly, immediately provided it after the opcode in the program memory. ماشي? In the program. So where is this data? It is in the program memory. Immediately after the opcode. Okay, the opcode is in the program memory, and I immediately provided in the following memory location the data I'm gonna perform my operation on. And to tell the CPU, so yani, if I go say load accumulator A, or you know what, let me, can I do this? Yes, okay. If I say load accumulator A, I use the number sign 55, or I do load accumulator A with 55, just like that. These are not the same, are they? They're not. In this one, A will be loaded with 0101 0101 اللي هي $55. While in this one, and where is the 55? If this is your program, yeah, in the program memory. So this has a machine code. Let's say its machine code is 183F, and this is just a suggestion, okay? Any assumption. I'm not sure. We can know the machine code from the instruction set. So 18F 3F. Then comes the 55. ماشي? So the 55, the thing we're gonna load into accumulator A, is in the program memory, while in this case it's not. While in this case it's gonna be like this. This is data memory, the SRAM, here SRAM, and there is a memory location address 0055 55, and something inside here, let's say مثلا 12. What's gonna go in this instruction be loaded to accumulator A is not the 55, it is the 12 hexadecimal, يعني 00010010. Clear? So if I put this number sign before the number, it makes the number an immediate. You don't go access it in the data memory. It is part of the instruction immediately available after the machine code in the program memory. طيب. ماشي? So this is the meaning of immediate addressing mode, that the operand is immediately available right after the opcode in the program memory. طيب. Okay, what did I do? How do I clear this page? A screen.
دكتور من البن اوبشنز اتوقع تقدر تمحيها.
Here erase all ink on slide. ماشي. Yes, thank you. Load X immediate 1000. Load X immediate 1000. It's just gonna put in X immediately the hexadecimal number 1000. So that's how I'm gonna represent it, okay? 1000. If I don't put this If I say load X 1000, I don't use this number sign, which means it's not immediate. This would go to memory address 1000, bring the operand inside this memory location and put it in X. ماشي? So it's gonna go to address SRAM 1000, get whatever in here and put it in X. ماشي? Well, now X is 16-bit, صح? While A is 8-bit, right? What happens if I load X? So here it's not going to get just the 1000, the 1000 and 1001. ماشي? And this is a different addressing mode, not the immediate. Okay, so I'm going to cover it. It is a direct addressing mode. So I'm going to cover it when I talk about direct addressing mode. ماشي? So let's concentrate on the ones with the number sign, immediate addressing mode. So if I load X, immediate 55, what will be put in X? X is 16-bit. 0055, صح? Because you need to fill the 16-bit. تمام? Okay. For this one, move W يعني move word. And I assume you guys, I asked you in our first meeting, all of you have studied microprocessors, so you have dealt with a microprocessor somewhere. So you should be familiar with this type of thing, the instructions, opcode, operand. Move word. A word here is a 16-bit number. Move byte is 8-bit. Okay, this is byte is 8-bit. B. Word is 2 bytes, yani 16-bit. So move word from here to here. If any of you dealt with Intel, it's the opposite usually. From here. So in Intel, this is your source and this is your destination, صح? But here it's the opposite. This is the source and this is the destination address. طيب. So this is telling us to move something from this location to this location. Now the source is an immediate number because this number sign is there, and I want to move it to somewhere where no number sign. So this is something with no number sign is a memory location. So this is telling us to move 10 hex directly into memory location of address 100. But I'm telling it to move what? A word, صح? A word يعني 2 bytes مش 1 byte. The 10 is 1 byte. طيب what are the other 2 bytes?
zeros.
صح؟ يعني ال 10 هيك بتكتبها صح؟ 10 0 0 1 0 if it's a word. So the other 2 bytes are zeros. Where will they be sent to? Memory location. And these are the high bytes, right? So they go to the low location. اللي هو 1 0 0 and هو 16-bit address, so there's a 0 here, 0 1 0 0, and the next byte, the higher byte, takes the lower the higher memory location takes the lower byte, so this will be 1 0 0 1. ماشي يعني إذا بدي أرسمها هيك, if I want to draw it, address 100 طيب وفي 0 1 قبل 100 then address 0101 and this is hexadecimal مش binary تخربطوش. Okay, so this is telling me to store a word 10 hexadecimal in memory location. Whenever I provide a memory location and I say I want to store a word into it, that means I'm talking about this memory location and the one immediately after it. طيب. So 100 and 101. I want to store a word here. The word is 0010 اللي هي 10 high immediate. So we use the big Indian convention. So the higher byte comes first, يعني in the lower location 00, and the lower byte goes next in the higher location, which is 10. ماشي? And I express it like this. The 10 goes to address 101. The higher byte, اللي هي 0, goes to address 100. Because I said move a word. If I said move a byte, it would just take the byte 10 and put it in memory location 01 $0100. ماشي. So to know about the immediate addressing mode, we're always using this hash sign, number sign, whatever, to indicate that anything behind that comes after it in the instruction is available in program memory immediately after the program code, and this is the data. While if I don't use this number sign, this means that this is an address, and go to the address to get the data. ماشي? Hope this is clear.
Yes, doctor.
The third addressing mode type is the direct addressing mode, where you directly provide the address. You directly provide the address right after the opcode. You provide the address of the operand. And the address here, see, if you go back here to the direct, if the address is 8-bit address, we all know that an address is a 16-bit, صح? Address is 16-bit. But if I give it the first 8-bit, then the other 8-bit, the higher, are all zeros. ماشي? 0, 0, 0, 0, 0, 0, 8 zeros. This is called, if I give it the lower 8-bit of the address, we call this the direct 8-bit address, with direct addressing mode with 8-bit address. The extended direct, you give it the full 16-bit address. You give it the full 16-bit address, and you don't assume that the higher 8-bit are zeros. ماشي? So in the direct addressing mode, you give it an 8-bit number, and it will understand to add 2 zeros, a byte, another byte of zeros next to it. This means load accumulator A with an operand. Now A takes 8-bit, صح? لأنه A is 8-bit. So I'm gonna go to address memory location, what? Address 0020, and get the byte from here and put it in A. ماشي? So go to memory location with address $0020, get that 1 byte and put it in A. Because A is 8-bit. While if I tell it load X 20 hex, this means that I need to load X with a 16-bit number, and I gave it an address 20. 20 معناته you add a byte of zeros as the higher byte of this address because the address has to be 16-bit. And I go get my operand, which in this case has to match the size of X, 16-bit, and go get it from this memory location, the 20. The 20. But 20, this location has only 8-bit. So I go to this, the 20 and 21, the one right after it, and bring it and store it. So X, if we assume that X is two parts, X higher byte and X lower byte, then the 0 will go to the higher part, and the 20, the 21 will go to the lower part. ماشي. Big Indian. Hope it's clear. Need more examples or clear?
لا clear دكتور.
That's clear.
Great. طيب, the extended direct addressing mode اللي هو number 4, just like this one, just like the direct addressing mode, but in our instruction we give it the address a 16-bit address directly. ماشي. In the direct, the non-extended direct, we give this number, we give it here is 8-bit. Now it's 16-bit. Everything else is the same. So loading accumulator A with a byte, because A is 8-bit, means go to address 4000, get the byte from here and put it in A. Load X from address FE60, مثلا هذا $F$, FE60. I'm gonna get 2 bytes because my X here needs 16-bit. طيب. So 60 holds 1 byte, and the other byte I get it from the following address, from FE61. I get this byte in the lower location and put it in the higher part of X, and get the byte in the higher location and put it in the lower byte of X. Big Indian. The only difference than from the first, the direct addressing mode, is that here you provide, when you write your code, a 16-bit number. Okay. Now, yani, why does this matter? The same. It matters because the size of this instruction is 1 byte less than the size of this instruction. ماشي? Because here you provide, so your program code will be shorter.
دكتور instruction ولا address?
Instruction. Where is this address part? Where is this address? Where is this address at? يعني أنا لما أجي أكتب machine code, I wrote this instruction. I wrote
program memory.
It's in the program memory.
Yes.
Right. So you know what? I think I should go open the instruction set. Show you an example. So load accumulator A. Let's search load accumulator A. طيب. If I search in the instruction set, load accumulator A. طيب. Isn't this text? Is this text? لا. I'll use the other manual, the CPU manual. Load accumulator A. This one. This instruction, see, if you use it with the immediate addressing mode, you load accumulator A with a number, you provide it immediately. Do you see the mouse or no? No?
Yes, دكتور. Yes, شايفين.
شايفينها الايد هاي؟ طيب هاي لود اكيوميليتر بي. طيب راح ماشي لود اكيوميليتر بي. وين راحت ايه؟ طيب هي قبلها. If you see the mouse, good. So if it's an immediate IMM addressing mode immediate, then the machine code is going to be 86. Then II is the immediate number. Yani if you search II is the number. Yani if I say load AA with number then 55, the II is the 55. طيب.
تمام.
Okay. Now if I give it the operand 8-bit operand, the direct addressing mode, DIR, without this hash sign, this is the machine code. 96, then DD is the direct address, the lower 8-bit of the address. The higher 8-bit are going to be zeros. But your machine code, when you look in the program memory, is going to be these 2 bytes alone. The extended, okay, the extended direct is this one, where you give it 16-bit address. ماشي. In this case, the machine code, the object code, the opcode is B6, then the higher byte of the address, and then then the lower byte of the address. Okay. I don't know if you see my mouse, and I'm not sure. Here, I'm here. Oops.
دكتور شايفين تمام ما في مشكلة.
Okay. طيب ماشي. The high byte, then this is in terms of memory location. So here in this addressing mode, I'm using 1 more byte. طيب, what are these? These are the access details. What's going to happen? هاي الرموز, these symbols R, P, O. Each one of them represents مثلا the R is a read. مثلا يعني what are the symbols? Let me show you symbols since we're here. It should be instruction at the beginning here. Okay, here, great. Where are they? Introduction. Not these ones. Where are they? لو شفناهم. Addressing modes. These are the ones we're covering right now. The symbols, see, they're also explained here. The symbols I'm talking about are, just 1 second, let me check. Maybe it's easier to find them here. They're here, يعني بس أنا I don't want to go. The symbols. هذول. Yes. What does an F mean? A small F مثلا. Free cycle. CPU doesn't use bus. G. Read P page internally. Register. P page is a register. I. Read indirect pointer. Read indirect. أبصر شو. And O. Optional program word fetch. P. If instruction is whatever. Program word fetch. R small 8-bit data read. R capital 16-bit data read. So if I go back here, وين احنا كنا بالload A. Let me search for load A again. LDA. ايوه. لا مش هون احنا وين كنا؟ يس بلا هون. Load accumulator A here. See? So what are we're at HCS12. RPO. What does this mean? Every letter here means 1 instruction cycle. So This will take 3 instruction cycles to execute the instruction. 3 instruction cycles. Fetch, decode, and execute. 3 times. If an instruction cycle مثلا takes 2 clock cycles or 1 clock cycle, whatever, this is 3 times. This is 3 as well. The load accumulator A. So here RPF, RPO. What is the difference? F is free. صح? F is free. We just saw it here. F is a free cycle. CPU doesn't use the bus. So the bus is free, which means the control unit can be using the bus at that time, fetching something else. The big O is optional program word fetch. It's gonna go fetch a program word from the program memory, a word from program memory. R small fetch, whatever, we saw it. طيب, look at the immediate addressing mode. It's gonna just take one clock cycle to execute, and 1 instruction cycle, let's say, to execute, because it's not accessing memory. Here is going to access memory in the next cycle, but the last one is going to free the bus. It's going to take 3 cycles to finish. Okay, these are the meaning of these words. The access detail and the number of these letters means the number of cycles, instruction cycles is going to take an instruction to execute. So in the extended addressing mode, we provided a 16-bit address of a memory location we're going to fetch our operand from. We fetch either a word or a byte. In the direct addressing mode, so I clear here, in the direct addressing mode, you provide an address of 8-bit. This means 2 to the 8 is 256, صح? So you are able to specify locations, memory locations in the range of from 0 to 255, اللي هو in hexadecimal 00 to FF, صح? While here, you're going to be able to address 2 to the 16, which is 64 kilobytes, the full window memory address space. Clear, huh?
Yes, Doctor.
Relative addressing mode. In this addressing mode.
دكتور بس لو سمحت.
Yes, Yazid.
ال A 8 بت وال X 16 بت مظبوط يعني ال 16 بت تبعت الاكستندد والهاي اللي هي اللوكيشن تبعها بس صح؟
Yes, the address هذه ما لها دخل. Yes.
تمام دكتور.
Yep. The relative addressing mode, it tells us that the operand this addressing mode is dedicated, used only by branch instructions. It's well stated. Branch instructions. The program counter usually points to somewhere in the program memory, to an instruction or opcode. In the relative addressing mode, you specify an address of a memory location of an instruction that is relative to where you're pointing right now. مثلا 5 locations after this one, or مثلا 8 locations before this location. So relative to the location where the program counter is pointing at. ماشي? So
يعني the program counter as reference عندي هون.
Yes, exactly, because you're talking about branching instructions. So مثلا this is an instruction, branch if clear. Branch if clear, you check the 0 flag. ماشي? You check the flag. If it's clear, you branch. If it's not, you don't branch. While this one, you branch if it's set, or not branch if it's not set. So you say branch طبعا the branch is in a memory location here pointed to, let me go to the other board with more space. So branch, oops, branch if clear to target. ماشي. So this branch of clear, and if I go search for this instruction in the instruction set, let's do it to get the idea. Branch if clear. Yeah, this one. If I go previous, this is in the table format. You can find this is it here. The machine code here is how much? 1, 2, 3, 4, 5, 6 locations. ماشي? Here, object code. Well, it depends on the addressing mode. And this is the worst case. This is the largest. This is the smallest. Let's say we took see operand. Okay. You check an operand. You provide a mask and then the relative location. You provide 3 operands here. Three things. This takes 1, 2, 3, 4 locations. 1, 2, 3, 4. So the branch 1, 2, 3, 4. This is the branch if clear. What are the bits? Here they are, or the bytes, or the R4F DDMM RR. هاي رموز هلا DDMM RR. R is the relative address 8-bit. DDMM MM is the mask. The DD is the operand 8-bit address. ماشي. So if the instruction is DDMMRR, so 4F DDMMRR. When we talk about instructions, we're going to look deeper here. So this instruction, if it, this is a branch if clear. مش تتار. you're going to check, you're checking for something. You know what? I should have gone to branch. Just branch. طيب branch check memory location 8-bit مثلا address 20 comma the mask is $01 and then address or the relative address مثلا 03. This means that go to memory, data memory, SRAM, data memory, address 20. You have a number here. Mask it with 1. The number here مثلا is إيش? 2F, $2F. You bring the 2F. ماشي. Mask it with 01. 01. do an AND. 2F is 0010 1111. AND it with 0000 0001. What is the result? 1 0 0 0 0. So is the result 0 or not? No, it's not. Okay, so I checked, I checked for this one. Branch if clear, it's not clear. It's not going to branch. But assume this was it was like this. لا راح يطلع 1. The one was here مثلا instead of 0 1 1 0. You're gonna get a 0. The clear, the condition is gonna be true. So you're gonna branch 3 locations after the one where you are at. Where are you at? طبعا the instruction is 4F. This is the instruction. This is program memory. Program memory. ماشي. The instruction is 4F. DD is the 20. Hi DD. بعدين MM the mask is the 10. احنا غيرناها قبل شوي. 10. And then the 03 is how many locations you're gonna jump So your program counter points here when this is instruction is gonna be before it's executed. Then it is fetched, right? Fetched, decoded, and executed. After this is fetched, the program counter automatically increments to point to the next instruction to be executed, the next instruction. So after the 4 bytes. So when this is executed, your program counter points here to address, مثلا, where are we مثلا in program memory? Let's say this is address 4000. This is address 4000. 4000. 2, 4000. 3, 4000. 4, ماشي? So the program, after executing this instruction, the branch of clear, the program counter is pointing at address 4004. The result of the execution of this instruction will add a 3 to the program counter. So it will make the program counter go +1,
0.7,
+2, +3, point here. ماشي? Which is address 4005, 4006, 4007. Okay? It is in the program memory. It is a branch telling go execute something here. But at the end of the day, it's part of the addressing modes because this is how you provided an address. We're still addressing a memory location, but with an instruction instead of data. But still we're addressing memory. Okay? Anyways, it's much easier when we write the code. But it's good to understand what's going on here. Okay, so relative addressing mode. ليش relative? Why is it relative? Because the address, the 3 I just provided in my example, is relative to where the current program counter is at. So +3 before it, or -3. Okay. In this addressing mode, it is used with branching instructions, short or long conditional branching instructions. Short and long, we're going to learn about it, how far you're going to be able to go. Short uses 8-bit offset. So the relative, the 3 we just used, it's an offset. Reference relative to where we're currently pointing at, +3 locations, -3 locations, +8 locations. Okay? This offset can be 8-bit. With 8-bit, you can address 256 locations, من -128 to 1 + 127. So you can make your program counter go 128 locations up before your currently location the program counter pointing at, or 127 locations after, if it's a short. If it's a long branching instruction, then you're using 16-bit to as a relative offset, 16-bit, and with 16-bit you address 64 kilobytes. Okay, 64,000 locations, 503
36
356 صح؟
36
split 36. 536, yes. You split them in half. Then the negative part below 0 is the memory locations before the program counter, and then 32K after the program counter. Tamam?
But Doctor, these numbers, assuming a reference is in the middle?
Yeah, this is the farthest. But we know that. Thank you, good question. We know that our window is 64K, صح? The window we can address is 64K, right? This is what you can address with a 16-bit address, right? So if you're in the middle, you can go to the very first location and you can go to the last location. But if you're here, you can go further, before up to 32K, but you can make it move forward up to your limit, اللي هو F, 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 F. You cannot make it go after. صح? You can it may roll over and go back to 0, 0, 0, 0. If you want to move to a location after the 64K window, then there is something called the P page register. We need to deal with it. We can move this whole window down. So, reference to your question, this is assuming that the program counter is in the middle, right? If it's not in the middle, if it's closer to the end or closer to the beginning of the 64K window, then your limit is the last address or the first address, which is the range from 0000 to FFFF. ماشي. Okay. Inshallah, this is clear.
تمام دكتور.
Extended relative addressing mode. However, the development environment we're using is a little smart. So we can write instructions like this, branch if minus, if the negative flag is negative, branch if minus. You can just write a label minus and then go write the minus here or the minus here with a colon. Then the program counter will move to here or here. Now, it is our responsibility to make sure that this is not, if I'm using a short or a long, a short, let's say, this is not further than 128 locations in minus, or this one is not further than positive 127 locations if it's a short branch. Okay. Usually you'll get an error, then you'll know that, okay, my label here, when we compile, this label will be turned into a number, into a number. We'll deal with that. But just to show you that this we can just use labels instead of going, just what I did right now here, the instruction size, where is the program counter doing, and then the relative, the +3 or -3. I don't have the reality to write a number here. I just can write a label, and the compiler will do all this math for me and do the branch, and it will know. انت بكون حاط هنا label. Okay, you say branch if clear to label. Otherwise, so you don't have to do what I did now to figure out that I'm going to branch to address 4007. Okay. Still have 1 minute. Indexed mode. Well, this one is a good one. Indexed with different types of offset. And then the indirect. I think with the half-minute left, I cannot start this right now. I'll keep it for next time. We're at the index addressing mode. I was hoping to finish. بصراحة. Next time we should finish and write code, and we should use the code warrior. Please, if you didn't install code warrior yet, please do. Okay. It's straightforward. And if you have any questions, you can stay. I'm going to stop the recording. And you can stay after the recording for any questions if you want.
دكتور إذا في مجال والله أنا ويزيد نياك شوي.
Yeah, okay, sure, yeah.